Alright, so in this video I'm gonna be explaining another important article with the title Transforming PageRank into an Infinite Depth Graph Neural Network. This is CML PKDD paper in 2022. Popular graph neural networks are shallow models, despite the success of very deep architecture in other application domains of deep learning. The primary reason for the shallow design results from over-smoothing, which leads node states to become more similar with increased depth. We built on the close connection between GNNs and PageRank, for which personalized PageRank introduces the consideration of personalized vector. Adopting this idea, we propose personalized PageRank graph neural network, which extends the graph convolutional network to an infinite depth model that has a chance to reset the neighbor aggregation back to the initial state in each iteration. We introduce a nicely interpretable tweak to the chance of resetting and prove the convergence of our approach to a unique solution without placing any constraints, even when taking infinitely many neighbor aggregations. So the node neighborhood is like n sub I. There's a set of all nodes connected to v sub I. Our approach inherits basic concepts and intuition from personalized PageRank, which we briefly describe here. PageRank, the paper in Google in 1999, was originally introduced to score the importance of web pages for web searches. I have a playlist for PageRank algorithms. In their work, web pages represent individual nodes in a graph, and links on these web pages are modeled as directed edges between these nodes. So the solution to PageRank is very easy. It's just a fixed point of this equation. And R is just dominant eigenvector of A. The vector R can be obtained by a power iteration with an arbitrary initial R0. For an intuitive interpretation of equation 1, we can interpret A as the stochastic transition matrix over the graph, providing a connection to a random walk. Therefore, the stationary probability distribution introduced by a random walk is the same as R in the limit. This also results in R only depending on the graph structure and not prior information available for nodes. Therefore, the authors also introduce personalized PageRank. So instead of R equal to AR, we say R equal to 1 minus alpha AR and plus 1 alpha U, which alpha is just teleport, which is a way to teleport back to personalization vector U. That represents the initial distribution over all pages. Because this equation here doesn't care about initial distribution. Is a even if they assume it's a uniform initial distribution. But here we are putting some kind of bias, some kind of inductive bias into that's saying that, okay, this is the initial distribution, but enforcing some constraints. And then you know about graph neural networks that here we aggregate, then we update, and this is the graph convolutional network, so we skip that. And you also know about over-smoothing. I have several videos about over-smoothing papers, over-squashing papers. Actually, when the number of layers grows, it becomes like applying a filter many times to an image. So it becomes many low-pass filters. So it becomes blur and blur and blur, and the nodes nearby becomes very similar. You cannot distinguish them. So you are ignoring the character, the identity of the nodes. And then infinite depth graph neural networks. So given an input matrix X and equation Y, with G being an infinitely recursive function, is well posed if the solution Y is unique, and G of X converges to the unique solution Y. Here is APPMP. This reference transferred this idea to message passing neural networks with approximate personalized propagation of neural predictions. That repeatedly, potentially infinitely many times, aggregated the neighborhood. They also add a chance of going back to the initial state. This is interesting. There is also a probability of this event that it goes to setting zero, setting everything to the initial state. They show that equation 5 is well posed for any alpha. So independently, Gu in 2020 proposed implicit graph neural networks. By adopting the general implicit framework, they obtained a fixed point solution of a nonlinear equilibrium equation. And now the pagerank graph out. So the solution of pagerank is the stationary probability distribution that is independent of the input. Given the close relation between pagerank and message passing neural network, the locality of the data and the influence of the input features also diminish with the message passing neural networks. As personal pagerank was introduced to prevent the loss of focus for pagerank, we introduced personalized pagerank graph neural networks that similarly assures locality of node states in the limit. Using the initial state f sub theta as personalization matrix for teleportation, personalized pagerank GNN can be understood as repeatedly applying graph convolution with a chance to teleport back to this initial state. We assure the convergence of PPRGNN to a unique solution. So our method allows an arbitrary amount of layers, potentially infinitely many, without suffering from oversmoothing. But do you really think that we have such a model in our brain? It's totally different. Our brain is totally different. Our brain is based on concepts. Something like mechanistic interpretability, compositional generalization. You don't see a cat just because of the features of the pixels. You see a cat because you have some kind of neurons are associated with understanding the concept of foreleg. Some kind of neurons are associated with two eyes, for example. Then we combine two concepts, becomes higher level concept. Then it should be either cat or dog. So you need even higher level concepts to distinguish cat and dog. So it's concept based. This is what cognitive neuroscience says. Also, it is related to category theory, what Kant said many years ago, this philosopher. But now in category theory in mathematics, that, for example, the application of that you can see in Haskell language, in functional programming, you see it is related to these ideas. So it's even the paradigm, what your brain is doing, intelligence is very different. And the sad thing is, the tragedy is that we are in 2025, we don't have any measure for intelligence. Do you have, for example, how many kilograms, how many watts? You have measure for everything, but we don't have any measure for intelligence. So you see that AI is in its infancy, and in the next 100 years, we will never even come to the point of being located in a rail that drives us to real intelligence in our brain, because our paradigm is totally different from the brain. The brain is asynchronous, it is spiking neural network, it's event-based, using conceptual generalizations. And so you see, so different from what we are reading in AI. So why do you expect that AI is any close to real intelligence? So we are nothing. We are computer scientists are nothing. Really nothing in comparison to Jesus Christ, who has designed our brain. So when I look at these articles, I really become sad, because we are too far from real intelligence, and these ideas are just made by copying ideas from others. Of course, some of them are very, very beautiful, but our paradigm is very different. Because our paradigm is very different, you don't love these equations, because the paradigm is very different. That's why I skip them. And even if you get the F1 score, what's the point? If your interpretability is not justified, if you don't have a good interpretable model, not explainable, so what's the point? So this doesn't matter anymore, because it may have understood some noise associating the wrong object to that, and many other reasons that we know from interpretability. So it's so sad that I should skip some articles that I don't feel they are bio-inspired. And we use these simple data sets, proteins. These are very simple data sets. Even if we get 90% accuracy, still, if you look at the explainability algorithms, for example, they have detected something that is not even mutagen. And for example, this one is not mutagen, but you get 95% just because of this part of that. So you see, without explainability, without trustworthiness, without interpretability, without privacy, we are too far from real intelligence.